Right now, across basically every developer forum, every Discord server, and your entire social media feed, there's this, well, it's an exhausting, deafening tug of war playing out over which artificial intelligence model is officially
Oh,
king.
it's everywhere.
It really is. I mean, today is Monday, March 30th, 2026, and the noise is just inescapable. You've got one camp posting these massive charts proving Claude is the undisputed champion of coding.
Right, the coding benchmarks.
Exactly. And then, like, another faction is just tearing those charts apart, claiming GPT's zero-shot reasoning is mathematically superior. And then, of course, you have the Gemini loyalists jumping into the fray with their own highly specific edge case benchmarks.
Naturally.
Right. It's just this constant, relentless debate about raw horsepower.
Which is, completely understandable from a psychological standpoint. I mean, we are drawn to the engine. We want to know the top speed, the torque, the raw specifications of the brain we're basically interacting with. But if you step back and look at what is actually happening in the trenches of software development right now, that entire debate is fundamentally missing the point.
Missing it completely.
Yeah. Obsessing over the model itself is, frankly, blinding developers to the actual bottleneck in their workflows.
And that blind spot is exactly what we are unpacking in today's deep dive. We're looking at this really brilliant breakdown by Daniel, a developer who goes by Solo Swift Crafter online.
Yeah, Daniel's work is fascinating.
It really is. He makes the argument that asking what is the best model is just, it's the wrong question entirely. We need to shift the focus from the intelligence itself to the environment we actually place that intelligence into.
Exactly.
And Daniel is someone who has genuinely lived this transition. I mean, he spent 8 years in the iOS freelance trenches, right? Designing interfaces, managing client expectations, basically building other people's dreams.
Which is a grind.
A huge grind. But then he makes this radical pivot after Apple's WWDC back in 2025.
Right.
He literally drops all his clients to go completely solo.
And, making that jump requires a massive leap of faith, especially in the economic landscape we've had.
Yeah.
But he didn't just survive that jump. He completely thrived.
Yeah, he really did.
I mean, he has shipped over 15 of his own Swift UI applications since then. And he's building this entire indie studio architecture completely in public.
Right.
And he isn't just churning out, low-effort AI-generated wrapper apps just to game the App Store algorithm.
Yeah.
He is building complex, scalable software. His livelihood depends entirely on his ability to multiply his own output using AI.
He treats AI as a critical infrastructure layer, not just some novelty to play with.
Yeah.
And his core thesis is that while 2025 was the year everyone got obsessed with the agent, the autonomous AI worker 2026 is definitively the year of the harness.
For harness.
Yeah. So today we're going to decode what harness engineering actually looks like at a mechanical level. We are going to explore this deeply counterintuitive trend where massive companies are finding out that deleting complex architecture actually drastically improves AI performance.
Which is wild to think about.
Totally wild. And we're going to walk through Daniel's highly specific, actionable playbook for setting up your own local environment.
So to really appreciate why the harness has become the defining engineering challenge of the year, we first have to look at the glaring paradox in how the industry actually measures intelligence.
Right.
Daniel points to this recently published Epic's agent study, which essentially holds a mirror up to the entire AI benchmark ecosystem. And it exposes how incredibly fragile these supposedly genius models actually are when you ask them to just do your job.
Yeah, let's unpack that benchmark illusion because it's so pervasive.
Yeah.
Whenever a new frontier model drops, the marketing materials always highlight these staggering numbers, right?
Oh, always.
It's like 95% on Python coding assessments, 98% on the bar exam. They paint this picture of an infallible machine.
Right.
But those standard benchmarks are fundamentally flawed representations of professional work. They're isolated, multiple choice questions or highly contained algorithmic puzzles.
Yeah, it's the equivalent of giving a student a standardized test in a perfectly quiet room, handing them a number 2 pencil, and asking them to solve a logic puzzle in a total vacuum.
Exactly. But professional work does not happen in a vacuum. The Epic's agent benchmark was designed specifically to break that paradigm.
Right. Instead of isolated puzzles, the researchers basically threw these models into messy, multi-step, real-world professional environments.
Yeah.
We're talking about the daily realities of consultants, lawyers, data analysts, senior engineers.
The real grind.
Exactly. Tasks that require a trained human professional to sit down, focus, and work continuously for 1 to 2 hours.
Right, tasks like, oh, okay, here's a massive directory of conflicting financial reports from 3 different subsidiaries. Cross-reference these PDFs with the raw data in this local SQL database, identify the specific discrepancies in Q3 revenue reporting, and draft a formatted internal memo for the CFO summarizing the legal risk factors.
Which is a beast of a task.
Right.
Yeah.
That is not a simple prompt and response. That requires sustained attention, state management, and the ability to pivot when you inevitably reach a dead end.
And when the researchers ran the absolute best, most advanced frontier models, I mean, the exact same models scoring 95% on those sterile coding tests through these messy 2-hour professional tasks, the results just completely shattered the marketing narrative.
Look, destroyed it.
Completely. The absolute best model available completed the tasks successfully only 24% of the time.
Okay, we need to pause on that. 1 in 4.
Yeah.
A 76% failure rate for the pinnacle of human computing achievement.
It's staggering.
And it's not like they made it unfairly hard. The researchers gave the models every possible advantage. They allowed the agents to retry the tasks up to 8 separate times, supposedly carrying over the learnings from their previous failures.
And even then.
Even with 8 attempts to get it right, the success rate only limped up to roughly 40%.
Yeah. And, the immediate reaction from a lot of developers reading that study was pure vindication. They thought, see, the models are overhyped. They aren't actually that smart.
Totally. A lot of victory laps on Twitter.
Right. But the researchers dug into the telemetry of those failures, and the root cause was something completely different. The models actually possessed all the requisite knowledge. Their zero-shot reasoning capabilities were perfectly intact.
Right? They understood the math.
Yeah, they understood the financial terminology. They knew how to write the SQL queries. They understood the format of a CFO memo. The failures were almost entirely categorized as catastrophic breakdowns in execution and orchestration.
They just got completely lost in the weeds. Like, if the financial analysis required 50 distinct steps, the agent would perform brilliantly for the first 15. Then, right at step 16, it would hit a minor snag. Maybe an API timeout or, like, a malformed data row.
Which happens all the time in real life.
Exactly. But instead of gracefully handling it, the model would just start to spiral. It would forget the overarching goal. It would loop back to a data parsing approach it had already tried and failed at 3 steps prior.
Yeah, the looping is the worst part.
And by step 30, it had completely lost the architectural context of the memo it was supposed to be writing in the first place.
The cognitive reasoning was definitely there, but the ability to maintain state over time just degraded completely.
I was trying to visualize this mechanical failure while going through Daniel's breakdown, and the clearest analogy I can think of, and this really stuck with me, is imagining you just hired the most brilliant, highly credentialed professor on the planet to join your startup.
Okay, I like this.
Right, so this person has a photographic memory. They have read every academic paper in your industry. Their raw IQ is completely off the chart.
That's perfect hire.
Exactly. You bring them into your office, but the physical environment you put them in is an absolute disaster.
Oh, no.
There are no filing cabinets anywhere. The desk is just this mountain of scattered, unmarked papers. There are 3 different phones ringing simultaneously. The fire alarm is chirping because the battery is low.
That captures the friction perfectly. Honestly.
Yeah.
Because it doesn't matter if that professor has an IQ of 180, if you hand them a complex 2-hour project in that environment, they are going to fail.
Absolutely.
They'll start strong, right? They grab a piece of paper, do some brilliant calculations, and then a phone rings. They get distracted, look down at a different pile of papers, lose their place in the original calculation, and eventually suffer a total breakdown in productivity.
Exactly.
The knowledge is entirely present, but the execution spirals into chaos because the infrastructure surrounding them does not support sustained, stateful work.
And that is exactly what solo developers are experiencing at their keyboards right now. I mean, they boot up Claude Code or Cursor or whatever environment they're using, and they ask it to refactor a complex authentication flow.
Yeah.
And they just sit there and watch the terminal output as the agent completely spirals. It writes a broken piece of middleware, tests it, sees the error, and then rewrites the exact same broken middleware 3 times in a row.
Yes. Or it completely hallucinates a database schema that it just correctly read 10 minutes prior.
Right. And when a developer watches that happen, the knee-jerk reaction is to blame the model. They think, oh, the AI is lazy. Or maybe the provider secretly downgraded the model weights to save compute.
The classic downgraded conspiracy theory.
Exactly. So they cancel their subscription and jump to a competitor, thinking a new engine will magically solve the problem.
But the Epic's agent data proves the engine is fine. We have to stop blaming the professor and start looking at the absolute state of the office we put them in.
Which brings us to a huge realization. If the model isn't the bottleneck, then the office space, the digital environment, wrapping the AI is the single most important variable we can control.
It really is.
And this brings us to the defining architectural shift of 2026. The entire industry is pivoting away from model obsession and aggressively moving toward harness engineering.
And, the term harness is highly descriptive here. We're talking about the comprehensive infrastructure layer that surrounds the core LLM.
Right.
It is the sensory inputs, the physical memory structures, the safety mechanisms. Technically speaking, the harness dictates the boundaries of the model's reality.
Okay, break that down for me.
Sure. First, it controls what the model can see, how the context window is managed, how logs are filtered before being fed back, and what state is preserved.
So it's basically the filing system for a professor.
Precisely. That's a great way to put it. Second, the harness defines the tool set. Does the model have raw bash access? Can it manipulate the local file system? Is it constrained by highly specific internal APIs?
Right, what can it actually touch?
Exactly. And third, and this is where most agents fail in the Epic's benchmark, the harness dictates the recovery and fallback loops.
Oh, this is crucial.
Yeah, if a script failed to execute, the harness determines whether the agent is allowed to endlessly retry, whether it must seek a different pathway, or whether it needs to just halt and ask the human for clarification.
And the validation for this shift isn't just coming from indie developers like Daniel. The titans of the industry are signaling that this is the new frontier. I mean, OpenAI recently published a deeply technical engineering blog focused entirely on harness engineering.
Yeah, I read that one.
Anthropic released a massive, dense developer guide solely dedicated to architecting effective harnesses for long-running autonomous tasks. But honestly, the most revealing case study comes from Meta.
Oh, the Meta story is wild. So Meta recently acquired an AI infrastructure startup called which was led by an engineer named Manish. And this provides an incredible look under the hood of enterprise-grade AI development.
Right.
After the acquisition finalized, Manish and his team published their internal context engineering lessons. And the headline admission in that document is genuinely shocking for a company of that scale.
It really is.
In the span of just 6 months, Manish's team was forced to completely tear down and rebuild their entire agent framework 5 separate times.
5 complete teardowns. I mean, I look at a data point like that, and my immediate reaction, and I imagine the reaction of anyone listening right now who builds software alone, is just pure intimidation.
Yeah, it sounds discouraging.
Right.
Yeah.
Because if Meta, a company with essentially infinite financial resources, a massive server farm of H100 GPUs, and literally a team of the smartest machine learning engineers on Earth, cannot figure out how to build a stable harness without starting over 5 times in half a year, how is a solo developer supposed to pull this off?
It's a fair question.
It makes the whole endeavor feel impossibly out of reach.
And that is the logical assumption to make, for sure. If the titans are struggling, the indie dev has no chance. But you have to look at why Meta was rewriting their framework.
Okay, why?
They weren't struggling because they lacked compute or because the math was too difficult. They were trapped in a cycle of rewrites because they were operating under a fundamental industry-wide misconception about harness architecture.
They were overbuilding.
Exactly. The prevailing assumption back in 2025 was that complex tasks necessitate complex management systems. Engineers looked at these brilliant reasoning models and assumed that to keep them on track during a 2-hour task, they needed to build massive, intricate, heavily railed infrastructure.
Right, all the bells and whistles.
Yeah, they were building management agents whose only job was to oversee the worker agents. They built custom routing logic, elaborate pre-processing and post-processing layers, rigid guardrails. They basically treated the AI like a dangerous, unpredictable component that had to be tightly restrained.
But the data they gathered over those 6 months of failure proved that their massive architecture wasn't helping the AI at all. It was actually suffocating it. Which leads us to the most counterintuitive discovery in modern software development. To build a vastly superior harness, you actually have to destroy most of the architecture you have already built.
It is the ultimate less is more realization.
It really is.
And Daniel highlights this brilliant case study from the engineering team at Vercel that isolates this exact phenomenon. Vercel was building a text-to-SQL agent, which is honestly a holy grail use case for a lot of enterprise software.
Yeah, let's dive into the mechanics of that Vercel story because it's fascinating. So a text-to-SQL agent is designed so a non-technical user, like say a marketing director, can type a plain English question into a chat box.
Right.
Something like, what was the churn rate for our premium tier users in the EMA region over the last 3 quarters, broken down by month?
A very standard but complex business question.
Exactly. And the agent's job is to translate that vague human intent into a perfectly optimized, syntactically correct SQL query executed against the company's database and return the formatted data.
And it is a super high-stakes operation because a malformed query can, crash a production database or return wildly inaccurate financial data.
Which is a nightmare.
Complete nightmare.
Yeah.
So naturally, Vercel engineered this agent using the heavy architecture philosophy of the time. They built a massive suite of specialized, handcrafted tools to guide the model.
Right. They didn't just give it the database. They built a custom tool specifically dedicated to reading and translating the database schema.
Yeah.
They built a separate, highly constrained execution tool for running the queries. They built a third tool just to validate the SQL syntax using abstract syntax tree parsing before it even touched the database, thinking, they were saving the model from making runtime errors.
They wrapped the whole pipeline in aggressive custom error-handling regex.
It was this beautiful, deeply engineered classical software pipeline, and it achieved an accuracy rate of 80%.
Which is catastrophic.
It really is.
Yeah. I mean, in the context of a consumer web app, maybe 80% uptime is a minor annoyance. But in the context of database querying, an 80% success rate means your data is completely untrustworthy.
Exactly. If 1 out of every 5 financial queries returns a hallucinated result, the tool is worse than useless. It is actively dangerous.
Yeah.
So Vercel is hitting their head against this 80% ceiling. They're trying to write even more custom validation rules, adding more regex, trying to manually patch every single edge case the model fails on.
Right. Until they decided to run a radical experiment. They stopped trying to hold the model's hand.
Yeah.
They took that massive, intricate pipeline and they literally deleted 80% of it.
Just gone.
Yeah. They ripped out the custom schema parsers. They deleted the specialized validation tools. They stripped away all the custom error routing logic.
They basically took all the guardrails off the highway.
Completely. Instead of specialized tools, they gave the agent the absolute most primitive raw access possible. They give it a standard bash terminal and basic read-write access to the local file system. They told the agent, look, if you want to understand the database, use standard command line tools like grep, cat, and sed to explore the files yourself, just like a human systems administrator would.
And the results of that deletion are what forced the entire industry to pay attention. By stripping away all of that custom, highly specific architecture, the accuracy of the Vercel agent skyrocketed from that break-in 80% baseline to a flawless 100%.
It's just amazing.
Right. The model was no longer confused by the rigid constraints of the custom tools. It could just use its inherent reasoning to navigate the raw environment.
And the jump in accuracy is incredible. But the secondary metrics are what really make this a true paradigm shift. By removing the custom guardrails and letting the model use raw bash, the token usage plummeted by 40%.
40%.
Yeah. And because the token payload was vastly lighter, the speed of inference, the actual time it took for the agent to accomplish the task, increased by 3.5 times.
That is wild. By deleting the custom software, the system became perfectly accurate, almost half as expensive to run, and astronomically faster.
Yeah.
For a solo developer, that is a complete revelation. Because when your local agent starts failing, the immediate instinct is to write a new rule. Like, oh, the agent failed to parse this JSON response. I need to write a custom Python script to pre-format the JSON before handing it back to the agent. You are constantly trying to corral the intelligence.
But Vercel proved that those micromanagement layers just introduce friction. Every custom tool you build is a translation layer that the model has to interpret. Every custom error message is a deviation from the model's vast generalized training data.
Right.
And Manish and the team at Meta discovered the exact same mechanism during their 5 rewrites.
Yeah, let's look at what Meta actually changed in those rewrites. Because they did add features, right? They aggressively pruned them.
Right. They realized their architecture was creating an unmanageable amount of noise. Manage looked at the telemetry and found that their agents were averaging around 50 tool calls per discrete task.
50.
Yes. Now think about the mechanics of a tool call. The model decides to use a tool, it generates a JSON payload, the harness executes the tool returns a massive log of output. That output is appended to the context window, and the model reads it.
Okay.
Doing that 50 times creates an absolute ocean of intermediate text.
Which brings us to a massive misconception about modern AI capabilities, the myth of the infinite context window.
Well, this is a big one.
Over the last year, the big marketing push from every provider has been all about context length. First, it was 100,000 tokens, then 1 million, then 2 million. The pitch to developers is basically, hey, just drop your entire monolithic code base, all your documentation, and all your server logs into the prompt. The model can handle it.
And technically, yes, the models can ingest that much data. The KV cache can physically store it. But from an engineering standpoint, dumping everything into the context window is a catastrophic design choice. Manish's team realized that while the model didn't suffer from strict amnesia, the performance degraded severely because the signal-to-noise ratio completely collapsed.
Let's dig into that signal-to-noise collapse, because this is exactly why the Epic's agents were spiraling after 20 steps.
Right.
Imagine you give an agent a highly specific instruction. Find the memory leak in this specific authentication module, but do not alter the existing encryption standard. That is your core signal. That is the vital instruction.
Okay.
Then the agent starts working. It makes a tool call to read a file. The harness dumps 1,000 lines of code into the context window.
Yep.
It runs a test script. The harness dumps 500 lines of stack trace errors into the context window. It searches the directory. The harness dumps a massive JSON tree of file paths into the context window.
And it's a build and build.
Exactly. By the time the agent is on step 20, your original vital instruction, the signal is buried under 20,000 lines of raw intermediate noise.
It's lost.
Going back to our genius professor analogy, the professor starts with a clear assignment written on a little sticky note. But every time they do a tiny piece of scratch math, they write it on a full piece of printer paper and just toss it on the desk.
Right.
Within an hour, the desk is buried under a mountain of useless scratch work. When the professor needs to remember the specific constraint of the assignment, they have to sift through hundreds of pages of garbage just to find that original sticky note. The cognitive load becomes overwhelming.
That is precisely what happens inside the transformer architecture when the context window is treated like a junk drawer. The attention mechanism of the model gets diluted across all that useless intermediate logging.
So how did Meta solve this?
Well, they didn't invent a new type of memory matrix. They actually utilized one of the oldest, most reliable systems in computing. They started treating the local file system as the agent's external memory.
It is such an elegant pivot. Instead of forcing the model to hold every single thought, every log, and every intermediate result in its active short-term context window, the harness instructs the agent to write key state updates to physical files on the hard drive.
Exactly. If you watch a highly optimized agent workflow today, you don't see a massive bloated context window.
Yeah.
You see the agent doing a small chunk of work, summarizing the result, writing that summary to a local markdown file, and then deliberately flushing its own context window to start fresh on the next step.
Wow.
Yeah, and when it needs to remember the broader architecture, it doesn't search its own massive memory. It simply runs a basic file read on its own summary document.
Anyone who uses Claude Code locally has seen this exact mechanism playing out in real time. You fire it up in your project directory, and suddenly you see a claude.md file generate out of nowhere.
Yes, exactly.
You open that file, and it is a perfectly structured, running to-do list and architectural summary of exactly what the agent is currently working on. It updates the file, checks off tasks, and logs blockers. It is actively using the file system to anchor its own reality so it doesn't spiral into the noise.
And what Daniel points out, which really elevates this entire discussion from just a practical coding tip to a profound technological reality, is that this convergence, Vercel stripping away tools, Meta offloading memory to the file system, Claude relying on a minimal core, is not a coincidence.
Not at all.
It is the real-world manifestation of one of the most famous, heavily debated theories in artificial intelligence research.
Right, this is where we have to talk about Richard Sutton and the bitter lesson.
Yes.
Sutton is this pioneering figure, one of the founding architects of reinforcement learning. Back in 2019, he published a relatively short essay titled The Bitter Lesson, and it has basically haunted AI researchers ever since.
It really has.
His core thesis is that if you look at the entire 70-year history of artificial intelligence, there is one inescapable pattern. Approaches that leverage massive generalized computation always defeat approaches that rely on human-engineered, domain-specific knowledge.
Always. And it's called a bitter lesson because human engineers and researchers kind of hate it.
Yeah, we want to feel smart.
Right. We want to believe that our cleverness, our deep understanding of a specific domain, is the key to creating intelligence.
You see this perfectly in the history of AI playing board games. Take chess. For decades, the smartest computer scientists in the world tried to build chess AI by hard-coding human chess strategies into the system.
Like heuristics.
Exactly. They wrote elaborate heuristic rules about pawn structures, knight outposts, and king safety. They tried to translate grandmaster intuition into thousands of lines of custom C++ architecture.
And those handcrafted systems were decent, but they definitely plateaued. It wasn't until IBM built Deep Blue, which largely abandoned deep human heuristics in favor of raw, massive, brute force search computation, that a machine finally beat Garry Kasparov.
Right.
And then, decades later, you look at the game of Go, which is infinitely more complex than chess. Humans tried to hard code Go strategies for years with basically zero success.
Yeah.
Then Google DeepMind built AlphaGo and eventually AlphaZero. And AlphaZero had zero human heuristics programmed into it. None. It was given nothing but the raw rules of the game and massive compute to play against itself, and it surpassed all human knowledge in a matter of hours.
The bitter lesson is that human-engineered complexity is just a temporary crutch that ultimately gets crushed by generalized compute.
Exactly.
So how does a paper from 2019 about board games apply to a solo Swift developer building iOS apps in 2026? It dictates the entire philosophy of harness engineering. As the core foundational models get inherently smarter as compute scales and reasoning improves, the harness we wrap around them must get simpler.
It has to.
Yeah.
If you are a developer right now and you are constantly reacting to new model releases by adding more custom Python scripts, more rigid routing logic, and more complex safety rails to your agent, you are actively violating the bitter lesson.
Yeah.
You're acting like the 1980s chess programmers trying to hard code pawn structures. You are fighting the natural evolutionary current of the technology. The intelligence is in the model. Your rigid, handcrafted harness is just creating brittle points of failure.
And Daniel drives this home by showing how the three most successful agent architectures in the world right now, systems built by entirely different organizations with totally different corporate mandates, have all converged on this minimalist philosophy.
Yeah, they all surrendered to the bitter lesson.
Exactly. First, we look at OpenAI's approach with their Codex framework.
So OpenAI utilizes this layered separation of concerns architecture. It relies heavily on the intelligence of the models themselves rather than a monolithic, rigid script.
Right.
You have an orchestrator model whose only job is high-level reasoning and planning. It hands off discrete chunks to an executive model that actually writes the code.
Makes sense.
And crucially, there is a completely separate recovery layer. When the executive model fails, the system doesn't rely on a massive block of hand-coded try-catch logic. It hands the failure back to an intelligent recovery model to analyze the stack trace and propose a new path. It is robust, generalized, and highly hands-off.
Then you look at the second approach, which Daniel actually uses as his daily driver, Claude Code. This is the absolute embodiment of Vercel's less is more discovery. The core harness of Claude Code is breathtakingly simple.
Yeah.
It consists of exactly 4 fundamental capabilities.
There's 4. It can read a file, it can write a file, it can edit a file, and it can execute a bash command. That is the entire core architecture.
It doesn't have a custom GitHub integration hard-coded into it. It doesn't have a specialized AWS deployment module. Anthropic realized that hard-coding those integrations into the core harness would bloat the system and violate the bitter lesson. So how does an agent with only 4 tools actually build and deploy software? This brings up a critical technical component. Extensibility is handled entirely through the Model Context Protocol, or MCP.
An MCP is the bridge that allows a minimalist harness to interact with a highly complex world. Instead of the harness knowing how to talk to a PostgreSQL database or a specific cloud provider, MCP provides a standardized JSON RPC protocol.
Okay, a standard protocol.
Yeah, it's essentially an open standard that allows the model to dynamically discover and communicate with external modular tools on the fly. The model just needs to know how to format an MCP request. The external MCP server handles the messy reality of the specific API integration. The core harness remains completely unpolluted.
Which is brilliant. And the third architecture is the framework Manish and the Meta team eventually arrived at after their 6 months of painful rewrites. Daniel summarizes their final successful framework in 3 words: reduce, offload, isolate.
Yeah, they aggressively reduced the context window size, actively filtering out intermediate noise. They offloaded long-term memory to the physical file system, relying on markdown files instead of the KV cache.
Right.
And they isolated complexity. If a massive data processing task was required, the main agent didn't try to do it itself and pollute its own memory. It spun up a temporary, isolated subagent, handed it the raw bash tools, and instructed the subagent to return nothing but a 3-sentence summary of the result.
It is incredible to see how OpenAI, Anthropic, and Meta all approach the problem from completely different angles, yet all arrived at the exact same conclusion. Trust the model's reasoning, strip away the custom guardrails, and use the file system to manage state.
Exactly.
But, understanding the theory of the bitter lesson and analyzing Meta's engineering blogs only gets you so far. As Daniel emphatically points out, every hour a solo developer spends debating theoretical AI architectures on Twitter is an hour they are not shipping actual products.
Yeah, theory has to translate into local, actionable workflows. That is where Daniel's deep dive becomes incredibly valuable for you as a listener. He provides a highly specific 3-step playbook for upgrading your own local harness today, without waiting for the next major model release.
Let's walk through that solo dev playbook. Step 1 is a direct challenge to your current workflow. Run the Vercel experiment on your own machine.
Yes. If you are currently using an agent framework, and you have spent the last few months building custom tools, specialized prompt wrappers, and intricate error handling logic, Daniel's advice is to back up your repository and then ruthlessly delete all of it.
Just nuke it.
Nuke it. Strip your local harness down to the studs. Give your agent nothing but raw terminal access and file system read-write capabilities.
It goes against every instinct a developer has to delete their own hard-earned architecture. I mean, you spent weekends building that.
It does. But you have to test the hypothesis locally. When you strip away the specialized rails, you will almost certainly find that the model is significantly more capable of navigating your code base using raw grep and find commands than it ever was using your custom, fragile search tools. You remove the translation friction.
Okay, step 2 in the playbook is where we implement the file system as memory concept. Add a progress file.
And this is the most immediate, high-impact change you can make to a long-running agent. You must establish a rigid read-write cycle anchored to a physical file. Before your agent takes a single action, the harness must force it to read a specific tracking file. Let's call it progress.md.
So this file isn't just a log, right? It's the model's architectural blueprint. It should contain the overarching goal of the session, the specific subtasks that have been completed, and the exact state of the current task.
Precisely. The agent reads the file, executes a small block of work, maybe it modifies a view controller or updates a database schema, and then, crucially, the harness forces the agent to write a summary of what it just did back to progress.md before it is allowed to move on.
This requires careful harness engineering because you have to handle the edge cases. Like, what if the model decides to overwrite the entire file instead of appending to it? Or what if it hallucinates the file path entirely?
Right, and that is where the minimal harness comes in. The harness shouldn't parse the model's intent. It should strictly enforce the mechanical read-write cycle. If the model tries to write to a non-existent path, the raw bash error simply feeds back into the prompt, and the model corrects itself.
Ah, I see.
By forcing this cycle, you anchor the model to a stable external reality. Even if the context window gets bloated with stacked traces, the model can always look at progress.md and instantly reorient itself. It cures the spiraling problem entirely.
Which leads us to the final, most technical step of the playbook. Learn MCP and modular skills.
Yeah. Once you have stripped your harness down and implemented external memory, you will eventually need your agent to interact with the outside world. Maybe it needs to pull a ticket from Jira or query a live production database.
Right.
The 2025 instinct would be to write a custom Python script to handle the Jira API authentication, parse the XML response, and feed it to the model.
Violating the minimal core philosophy.
Exactly. The 2026 approach is to use the model context protocol. You run a lightweight MCP server locally. The MCP server handles the messy reality of the Jira API. Your agent's harness remains completely pristine.
So clean.
The agent simply sends a standardized JSON request to the MCP server asking for the ticket, and the server returns a clean, standardized response. You maintain a minimal core while gaining infinite extensibility.
This shift in architecture requires a massive shift in mindset, which Daniel captures perfectly when discussing his community platform, crafterslab.dev. He explicitly designed this community to be the antithesis of the typical AI content farm.
Oh yeah, the internet is flooded with those.
It's not a graveyard of copy-pasted ChatGPT prompts or flimsy build an app in 5 minutes tutorials. It is a home base for developers who are transitioning their mindset from treating AI like a vending machine to treating it like a junior pair programmer.
And the vending machine analogy is how the vast majority of people still interact with these models. You walk up, insert a prompt, press a button, and expect a fully formed, perfect piece of code to drop out.
Yeah.
And when it doesn't work, when the code gets stuck, what do? You shake the machine, you get frustrated, you type in all caps, you complain on Reddit that the model has gotten lazy.
Yeah.
It is a highly passive, highly fragile relationship.
But when you adopt harness engineering, you realize you are working with a brilliant but easily distracted junior developer. You don't just hand a massive project to a junior dev and walk away.
No, of course not.
You set up their environment, you give them a clear project management board, you check in on their progress, you ensure they have the right access permissions, you build the infrastructure that allows them to succeed.
And Daniel is radically transparent about what this infrastructure looks like in practice. He isn't selling a polished theoretical dream. On crafterslab.dev, he opens up his actual daily workflow. He shares the raw.md files he uses for external memory.
I love that.
Yeah, he shares his complete Swift brain repository, which is how he injects domain-specific Swift UI knowledge into his local context without bloating the window. He shares his raw terminal automations.
It's the messy parts in all approach. He is essentially saying, look, here is the exact scaffolding I am using to ship real apps right now. Clone it, break it, and adapt it to your own machine.
Yeah.
And this is critical because it solidifies the concept of the indie stack. Solo developers are no longer building in isolation. They are collaboratively figuring out the mechanics of this new technological paradigm.
The goal isn't to build a perfect AI. The goal is to build a highly resilient environment so that you, the human developer, can radically scale your output. By ignoring the benchmark noise and focusing entirely on the harness, you stop fighting your tools and start actually shipping software.
We have covered an immense amount of architectural ground today. We moved past the illusion of those 90% benchmark scores, digging into the Epic's agent telemetry to understand why models fail at real work, not from a lack of intelligence, but from catastrophic execution spirals.
Right.
We explored the counterintuitive reality discovered by Vercel and Meta that in the era of massively capable models, complex hand-engineered architecture actively degrades performance.
Yeah.
We saw how stripping away custom guardrails, adopting raw bash tools, and relying on the file system for external memory drastically improves accuracy, lowers token costs, and increases speed.
And we contextualized all of these industry shifts within the framework of Richard Sutton's Bitter lesson, understanding that as raw compute scales, minimal harnesses utilizing protocols like MCP will always outperform rigid, human-engineered pipelines.
And we broke down Daniel's playbook, giving you the exact steps, the Vercel experiment, the progress.md read-write cycle, and the implementation of modular skills to upgrade your local environment today.
It's totally actionable.
It is. You have total agency over this. You don't have to wait for the next massive AI keynote to fix your workflow. The power to build a better teammate is sitting right there in your terminal. 2025 gave us the autonomous models. 2026 is about mastering the environment we put them in.
It is the evolution from simply prompting an intelligence to actively engineering its reality.
But before we completely sign off, I want to push this concept to its absolute logical extreme.
Oh boy. Okay.
We talked extensively about the bitter lesson, the reality that as models become smarter, our handcrafted harnesses must become simpler. We saw how Vercel deleted 80% of their tools and how Claude Code relies on just 4 basic functions.
Right.
The trajectory of the entire industry is pointing toward absolute architectural minimalism.
The harness is shrinking as the intelligence expands.
Right. So take that trajectory and run it out 5 or 10 years. If computational power continues to scale exponentially, and if these models cross thresholds of reasoning that we cannot even fully conceptualize right now, does the perfect ultimate harness eventually become nothing at all?
Oh, wow. Are we simply living in a transitional era? We look at harness engineering today as this brilliant, vital skill. But is it just temporary scaffolding? In a decade, will these entities even need our carefully formatted .md files, our bash constraints, or our localized MCP servers? Or will they reach a point of such comprehensive awareness and perfect state management that the environment and the intelligence become indistinguishable from one another? Will they simply just do?
That is
Well, it forces you to wonder if the environment we are so carefully engineering today is ultimately just training wheels for an intelligence that will soon outgrow the need for a physical hard drive altogether.
Something to think about the next time you watch that cursor blinking in your terminal, waiting for your AI teammate to write to its Claude.md file. Keep experimenting, keep breaking your architecture, and we'll see you next time.